The following video shows results from the KisPo research project, AI method for the control of digital gantry robot twins. The KisPo research project was funded by the Hessian Ministry of Science and Art as part of the LOIWA program. The funding started in January 2022 and lasted 2 years and 3 months. The challenges facing the manufacturing industry in the light of Industry 4.0 require new solution concepts in many areas. As part of the KisPo project, an innovative solution concept was developed for the area of conveyor technology and production. The aim of KisPo was to develop autonomous and self-learning control software for so-called gantry systems based on machine learning and simulation methods. In gantry systems, shown here by the gantry manufacturer FLT, trolleys move fully automatically, horizontally, along an axis to production machines for loading or unloading. The vertical movement towards the machine is performed by a so-called gripper. According to the current state-of-the-art, gantry systems are controlled with the help of simple priority rules, which are often defined once, based on experience and then stored hard-coded in the control system. Digital twins in the form of simulation models are used for the planning of gantry systems and the validation of control systems. In KisPo, agents, so-called RL agents, were trained with the help of such models and the reinforcement learning approach, which can take over the control of the gantry independently and autonomously. The RL agent was developed on the basis of a DeepQ network, DQN. Neural networks are used for the agent's learning process. The agent learns the strategy for controlling the gantry from its interaction with the simulation model. The current status of the gantry system is transmitted from the simulator to the agent via an interface. The agent finds the appropriate action for this and transmits it to the simulation. Here, the action is executed and the next action is requested together with the new system status. Gantry systems have different characteristics, depending on parameters such as the number of machines or the types of loaders used. In KisPo, 19 different configurations were examined, which can be summarized in the following categories. Gantries with one eye loader and a different number of machines to be loaded. Gantries with one H loader and a different number of machines to be loaded. Gantries with two eye loaders and a different number of machines to be loaded. You can now see the validation of a model with 3 production steps and 2 machines per step. The gantry has a carriage with a single gripper. The machines can break down and the feed via the conveyor is irregular. In the validation, the RL agent, light blue, was able to achieve a statistically significantly higher throughput than a conventional heuristic, orange, based on the shortest travel distances. In another model, the gantry is now served by 2 eye loaders. Here again, the RL agent can achieve better results than the heuristic. At this level of complexity, it is necessary for the heuristic to limit the travel ranges of the trolleys, while the agent learns the control independently using reinforcement learning. Furthermore, the travel paths of the agents were analyzed using approaches from process mining. These provide users and production engineers with insights into the behavior of the learned control strategy of the agent and thus make it easier to understand.